Okay. So we are going to burn iron. What is burning? Combination with what? With O2, says Kish. With oxygen. Okay? Can we obtain carbon dioxide? No, because we don't have carbon here. We have iron and oxygen. What are we going to obtain? Iron oxide. So we are going to write down the information about iron oxide. You remember that iron oxide can have two formulas. When we burn iron, we are going to obtain the iron 3 oxide. So the formula is this one. Okay? Now, in the lab that we are going to do on Tuesday, we are going to burn iron, and we are going to calculate and measure both separately how much iron oxide we should obtain and how much we obtained, okay, in the lab. So for that, we need to know how to calculate this. So for calculating things based on the formula, we are going to use moles, masses, atoms, and so on. The same thing that we did with the simple problems that we were doing. It's all ratios. So the first thing that we need to do for calculating anything in what we call stoichiometry, that is the chapter, you will be copying, should be very good for you to copy the things, okay? So for this one, we are going to see how we make the calculations. So I'm going to give you the step-by-step that you need to know or you need to do every single time that you need to make a calculation. The first thing that we need to do, what do you think it is? Balance. Very good. Balance the equation. So the first step is going to be balancing. This is very slow, so I'm going to use the other one. Balancing the equation. So I'm going to balance the equation. And can you tell me how can I do that? In front of what? 1, 2, and 3. Here? 2. Oh, 4. Good. 4. And 3 here. Let's count. We have 4 irons here, and 2 times 2 is 4 irons. 3 times 2 is 6 oxygens. And 2 times 3 is 6 oxygens, because these two affect the other one as well. Is that okay? Now we can begin calculating things. So the second step will be adding the masses. I don't know why this is so slow. Okay, so I'm going to erase this 4 because it's very, yeah, I don't like it very much. Okay, can you calculate 4 moles of iron? Please. How do you do it? The molar mass of iron. And where do you get the molar mass of the iron? From the periodic table, which is 56. Very good. So it's going to be 56. That is the molar mass. How many moles do we have in the reaction? 4. So it's going to be 4 times 56. Okay, and that is the mass that we are going to use for our calculations. So every single time you are going to calculate the molar mass of the compound or element that is reacting or that is produced, and then multiply by the amount of moles that are present. Okay, the same with the oxygen. Each oxygen molecule, each mole of oxygen molecules is going to have the mass of the molecule expressed in grams. Okay, so in this case it's going to be 32, okay, times 3. And this is in grams, guys. And this is in grams as well. And this is grams of iron. We need to put the units. And this is gram of oxygen. What happens with this one? How do we calculate that? Yeah, we can have these two adding together and they should give me this one. But if I made a mistake, it's better for you to calculate these individually and then check with this one, and it should be the same number. So it's going to be 56 times 2, so it's 112, plus 16 times 3, which is 48. If my math is not wrong, that is 160 times 2 is 320 grams. Okay, so these numbers, all these calculations should give you 320 grams. Yes? Now, which is the problem that, can you give me the numbers that we have? 4 times 56 is going to be 224. So I'm going to erase this. I'm going to put 224, so I don't have, so 224 here. And 32 times 3 is 96. Yes? Okay, I'm good at math. 96. Okay? What does this mean? That if I have 222 grams of iron, we will need 96 grams of oxygen to react completely and form this one. So now we can make calculations. For example, we are not going to take 224 grams of iron and burn them